I'll keep this. I'm going to keep this brief. Anyone here a member of Uptime or the Green Grid? No one? The Green Grid and Uptime Institute are going about working to create a metric to define how efficient your data center is running. Uptime Institute's East Coast branch, self-managed, non-profit organization. The Green Grid is a consortium run by a lot of West Coast, Microsoft, Cisco, very involved. So what the metrics that they've created is called efficiency, is sustained by the Uptime Institute, which is something that you predominantly hear on the East Coast, as the Uptime is based in New York City. PUE is the West Coast standard developed by the Green Grid, which is Microsoft. They've teamed up with the Department of Energy. This standard is becoming, it's probably the most common terminology within your data center efficiency. The basic definition is a metric used to determine the overall efficiency of the data center, created by taking your total facility load, dividing it by the amount that you're actually applying to infrastructure, which would be switches, servers, your critical hardware. The third metric, which is only defined by the Green Grid, is the data center infrastructure efficiency metric, which a lot of you are facilities planners. It's the metric that's least commonly used, but seems to serve the best purpose for gauging the efficiency. Because when we're talking about efficiency, green's a really nice word, but I think the green that we're most concerned with is probably saving dollars at the end of the day. Saving the trees are nice, but saving cash and making your CFO happy is what we're really going after. So DCIE is I've broken it down, just given simple formulas for converting watts to amps, given the tonnage of crack needed. I'll skip into these. So we have POE and COE, same terminology, defined a little bit differently, just written a little bit differently. But DCIE is a reciprocal of POE or COE, which gives you a percentage. So if you're running at 33% DCIE, that means for every kilowatt of power that your server load is taking, 33% of that is dedicated to cooling. If you have a server drawing 1.5 kilowatts, 500 watts of that is being expended on non-critical facility expenditures, lighting, air conditioning. It's an important metric to do, and it really seems to work out well. Question? But we brought a sheet with this information on there, and
some good references.
Yeah, just some good references. PUE is a very common terminology. You come across it in pretty much all the literature. So we just thought we'd give you a brief overview.
What we're going to talk about is cooling next. Cooling concepts. Many different ways to deal with this. Seeing a wide variety of interesting and cheap things are done. I've seen things where people just simply went to Walmart and brought box fans in for a while. What's actually the worst case, where people are just taking the back doors off and hoping it works and hoping no one comes into it. But you still want to maintain security within inside the data center, and you still want to maintain cooling. Basic one, right here, level one, standard hot aisle, cold aisle concept. Front rear vented doors, mesh doors, what we're going to call them, I call them per, vent, whatever. We have to worry about the amount of mesh and the open area of the mesh itself. Within that hot aisle, cold aisle, front to rear, horizontal, standard flow of servers, you have to make sure that you can get in and get back out. There are fan assist methods to do that as well. You have intake fans on the front door that blow right in. You can have exhaust fans quickly back out there as well. Now, anytime you add an extra power or a thing that goes to your cooling, you have to maintain your redundancy with it. There are options, there are products out there. Some of the PDU companies have some really nice products that actually have dual power input for another optional cooling fan. And we can definitely promote that. It just doesn't get the cost for redundancy. You build so much into this rack, so many dollars, and you're relying on a $50 fan hooked up to a power strip. You want to make sure you have your redundancy into it. And those are all remote monitoring and remote, you would go back up. I'm going to kind of go down through each one of these just as a general rule. So I did some assumptions, as always, will hurt you. But what we're seeing is, in the cold aisle, you hope you're running 63 and 68 in the cold aisle. But what we're seeing, even in the cold aisle, in this type of method of vented door, you're getting only 65 to 72, actually with the service actually intake. So it's already heating up as soon as it passes through the front mesh of the door. So once it goes through that, maintaining all your cable management, all the short circuit brush grommets, keeping the air not bypassing the equipment. So we're hoping you're getting 90-95 in the server exhaust, and then that still has to exit the enclosure as well. So you're having another pressure drop going through that mesh behind the server and exiting the rear mesh door. So you're actually having an increase in the buildup in between just the rear cabinets that we all see. And then actually in the hot aisle, you're getting, hopefully, in the 85. So it's actually cooling again and getting recirculation. So what we're seeing with this is that you're getting recirculation exhaust around the intake, causing the crack units to be less efficient as they have to cool all the white space. And the white space is a term I'm using is anything that's not where any open floor tile space. Side aisles, main aisles, hot aisle, cool aisle, calling that just white space. So what we're seeing with this, I mean, if it's managed properly, you can get anywhere at 4 to 6, and sometimes some people are pushing that a little bit more, depending on the power. The next version is, all right, you've got to get the heat out. Get the heat out of the cabinet and get the heat out of the room itself. This is the next simplest level to take it to. You still have standard cold aisle, so all your perf tile and your raised floor application. Obviously, there's no perf tiles in your hot aisle at all, and only in the cool aisle. But then you have the ducted exhaust. So now you're not heating the room at all. And you don't have to actually cool the air anymore from the heat blowing around the cabinet, over the cabinet, some recirculation, depending on going around pillars and pylons and everything else. So what we're able to do here is still get 63, same thing, 65 at the server intake, you're still getting that. But what we're getting is a little bit more heat load inside the cabinet because you don't have that extra buildup behind the server equipment and the mesh door exiting the rear enclosure. That actually is just drawn and ducted right back to the crack unit. So you don't have to, you have 100% heat going right back into the crack unit.